We are from the University of Technology from Dresden, and we bring a little bit of a different approach today. We learned a little bit, or actually a lot, about how you guys teach Zephyr, how you start teaching embedded systems, programming and stuff, and we, I think, start a little bit later in this journey. We clustered our talk the following. Of course, we would like to introduce a little bit why we use Zephyr. There's also a little bit of a, I think, a private story behind that. We were not always at university. We came back. We explained that a little bit why and why we choose to use Zephyr and how we are able to use this in the curriculum at Professor Michler's chair and why he gives us this freedom and why he trusts us that he says, okay, you guys do whatever you like. Regarding Zephyr and teaching students that we have at our chair the latest technologies regarding connected devices, because we are mainly in the field of RF and wireless connected devices, IoT connected devices, and we are, in hard words, we do not care about things blinking. We need things to perform in the real-world application or in a real-world scenario, because students on the one hand, projects on the other hand. And we would like to explain this a little bit. This is our professor, just that you have seen him. This is Professor Oliver Michler. He is the head of the chair. And he has also a strong background in electrical engineering and a strong focus in information technologies.
Yeah. First, a word where we come from. University of Technology in Dresden, okay, but we have a special faculty, the Faculty of Transportation Systems. This is quite a unique faculty because it deals with all kinds of mobility. And one topic is our topic, the Institute of Telematics. That means we are on the chair of Transportation Systems Information Technology. That means on our chair we have two groups. Basically, one group is positioning and the other group is communications. And in positioning group, we deal with satellite-based navigation systems. This is one specific topic, and the other one is positioning with wireless sensor networks, with technologies like ultra-wideband or Zigbee or the new thing, Bluetooth. And the group we are in is communications, and we deal with the story about how gets information from one vehicle to another. And with vehicle, we really mean vehicle because this can be anything that moves in our world. So we have, we call it test carriers. This is passenger cars. This is trams. This can be boats, and this can be railway systems, and this can also be planes, airplanes.
Exactly. And you may ask, why are two people are standing here? I mean, this is not that common. Usually just one presenter is here. We decided to do this like our lectures. We also kind of structure our lectures we talk to each other. We also like to encourage you to join this kind of conversation to make it a little bit more open. And we got basically a very good feedback for this kind of style presentation to make it a little bit more fresh. Also, we would like to say that we know each other for a long time. We started studying electrical engineering at TU Dresden a long time ago. I see there, and now we have more or less lectures in theory and techniques and information technologies. What this especially means comes in some slides. We will talk about this. We also teach sensor systems for traffic telematic application, dealing with temperature sensors, like Kevin said. By the way, this is Kevin, this is Sven. Hi. And we basically talk about sensor systems and kind of actuators you see in the real world, in the real kind of real world applications, basically. And also our traffic telematic networks. And Professor Michler said to us, okay, make this up to date. And once he said that, we have seen kind of a chance. Before joining Professor Michler's chair, we were in a little startup. And like Tobias said, if you have never ever experienced designing a product it's very hard what you actually what you teach people when it comes down to a real product. When we were at the startup, we had no idea. We had no idea about certification of wireless products. We had no idea what is a good software, what makes a software a good software. Like we said, we studied electronic engineering years ago. We had lectures in embedded controllers. People telling us the C167 from Infineon, 60-bit microcontrollers, state of the art. Keil, microvision, no Keil bashing, great tool for getting started. But this was our world to this point. And so we decided, hey, startup sounds like a good idea. We can make IoT products. We actually managed in 2019 to make a kind of more or less real-time constrained IoT tracker in a bare metal application. We are pretty proud of that. It's not a good design, it's not a good approach, it's definitely not worth the money at that point of time, but we learned a lot. And this is where Kevin came around and said, hey, take a look at this. This is Zephyr. What is Zephyr? Zephyr, real-time operating system. These were new words to us, despite the fact that we had already our diploma degree in electrical engineering. So this is where we kind of reimagined, okay, maybe we can use this kind of new technology when we left this company and joined the chair again. Maybe we can make use of this. Because our mission for almost 10 years, make sure technology works, still the case now. Our colleagues also come to us if basically hardware needs to work, software needs to work. Those two guys, maybe they have the answer. Maybe not always the right answer, but at least we have an opinion.
More than one.
More than one. And this is where this whole journey started, I think, when 2020 at this chair. So basically 5 years of Zephyr experience under the belt regarding real products, or university-like products, and lecturing. Okay, so what is this chair dealing? Or Kevin already said this, we are basically hands-on approach. Like he said, a lot of vehicles, maybe boats, maybe airplanes. Everything comes into play. We see a lot of measurement equipment. Also, our students have the chance to kind of deal with equipment worth more than a state-of-the-art Porsche. And this is kind of a unique situation for us. We really like this luxury situation, so to speak, to give the insights we learned over the last years, also with the colleagues from the industry, what it comes down, what matters, what you need to take care about to make a product a good product, also with an engineering point of, well, from an engineering point of view. Okay, so basically a little bit of a background. So why did we basically choose Zephyr? I already told you, because we said, why not trying something new? Why not trying something state of the art? We had kind of some marketing slides. You already know the benefits, but the idea behind that was because Kevin said, I come from the Linux world, and now tell us, why is this a good idea?
So the Linux world, everyone in this room may have experienced the Penguin. I personally think Zephyr lives the spirit of the Linux world for embedded devices. That means modularity, open world, hands-on approach, everything on board. So there's the batteries included approach, I guess. So, and this was, at the time we discovered Zephyr, it was a great benefit that this big mature system of Linux steamed down in the embedded world. And you saw in the previous slides that Sven is the master of the hardware. And we try also to get this vision to our students and to the project world. We'll show you, because the hardware and the software world, which is more my domain, they meet in the middle, in the embedded systems space. So we do both worlds in the embedded systems. Every one of us has his own specialty, hardware and software. But in the middle, we need something that we can share work, that we can offload work to the students, that we can offload a little bit work to maybe subcontractors or stuff like that. So this is where Zephyr comes into place, and because we deal with wireless sensors and wireless systems, the IoT space comes into mind. So this is what we need. These are our needs. Then we have the embedded systems world, and then we have the security world. More and more important, we try to give our students also the necessary that security is not a nice to have, but it needs to be designed into the product.
Exactly. And this is where we basically decided to use, or this is why we decided to use Zephyr and give our students kind of the abilities to use that. I maybe think we can skip that because of time, understanding the operating system. We heard that a lot today. Give you a little bit of an overview where we basically start. Like I said, we do not really care about hard words, but if the LED blinks or not is not important for us in this point of time, because students coming to us basically have learned this. They maybe started out in a different way, maybe with Kyle, still taught by some professors, which makes the life for us not that easy in some points, because of course we have to tell them a little bit about device trees, about the build system, about the ecosystem, but like we learned today, it's maybe not easy, but we don't tell our students that it is not easy. Kind of relying at this point heavily on the Nordic Dev Academy, to be honest, because we think for getting started and just to see if it works, they are doing an amazing job. Of course, it's the point of view from the Nordic company, but for people never ever having dealt with Zephyr, it's maybe a good starting point. And like I said, we are starting in the 5th semester and more or less starting with theory, theoretical stuff regarding wireless systems. So basically we teach them when it comes down to antennas, when it comes down to matching stuff and basically hardware related stuff. This is where we first start to show our custom builds basically. Also custom builds meaning hardware, PCBs, where we tell them on real hardware we use in projects or we have used in projects, which Zephyr runs basically, and what it is important there. So basically from there we start building on traffic telematic network systems, teach them MQTT, teach them CoAP, teach them UDP, TCP, you name it. And the thing is, when relying on Zephyr, basically we can show students how easy it would be if you have a connected device and you kind of understand your project configs and your device trees. Of course, we help them out a lot, but in the end, they should be able to kind of run a connected application on their own. And this basically comes all the way up to the 7th semester, where they also try to incorporate their own algorithms. Very important, like Kevin said, we are dealing a lot with connected devices doing things. Doing things meaning maybe Bluetooth 6 channel sounding application where it comes down to find a good algorithm using Zephyr, build it inside your Zephyr project and get the distance out of it. And basically we would like to encourage our students, okay, maybe that's not that, maybe not that complicated. You have this board, you have the setup, it runs kind of out of the box with a little bit of help. And now you have the chance to write your own code. Use it in there and get a great result, product, whatever. And the idea behind that is also to encourage that maybe the world does not end with the Zephyr examples in this point. So basically we talked to Nordic guys and they said, okay, our world ends exactly there. You get the channel sounding capability, you get a rough estimation, do whatever you like with that. But this may be not a good value or maybe not a good result. And this is what we like to encourage our students also. If you have a good algorithm, why not play it back into this ecosystem that everybody can participate? I mean, why not?
Yeah. I mean, to add to this topic, we had 2 student works in the last semester, and they were dealing with this channel sounding approach. So 2 students, one was more computer science related as the other one, but they both got it working, and they both measured results. Also in the what you see on the slide, the anechoic chamber, where you have the laboratory where we can measure wireless devices without interference from outside world. They did measurements in this lab and also in the outside world to get the real measurement data, and they have succeeded so far without deeper knowledge of the tech stack behind it. Because, like Sven said, we start from a higher level. And this approach also works for students not being so much deep into the rabbit hole of bits and bytes, so to speak.
Exactly. And we also try, more or less, to also bring our project or our research project outputs into the classroom. Meaning that devices, or let's call it light products, which we have built for specific research topics, maybe in the tram, we can show a picture of that, or maybe in the Verkehrsunfallforschung, that we bring those, interesting story, we can talk about that later. Those devices performing somehow, that we bring this into the lecture, that the students also see, okay, this is manageable, this is doable, okay, this is using MQTT, I understand the basics.
We teach them the ISO-OSI.
ISO-OSI, yeah, model, and basically exactly those kind of, features Zephyr already brings, that you can always have it under the tip of your fingers, just by entering a config and it works out of the box. This is basically the idea. Also this whole security concept. Kevin, what is this security concept telling us?
Yeah, what we see here is what Sven said. We have a tracker application. We show you then in detail, and also in the hands-on, we have it with us. We teach them in one of our lectures that it's important to have security enabled, of course. And we teach them the ISO-OSI layer model. And by that, they interact with the different layers and are now able to recognize which layer they are on and which layer they are enabling. And what happens if I switch on another layer, or that I can swap layers out without missing functionality, or adding new functionality, or adding new physical channels, for instance. And what we see here is the combining of the two worlds, as we said. We also do the right-hand side. So the back-end side, we deal with protocols like MQTT, CoAP. We deal with serialization protocols like protobuf, etc. And we deal also with database schematics or schemas. So we want to give them the whole picture so that they understand also the project work we are having. Yeah.
Exactly. Exactly. And we also brought some of our demo devices here to showcase. And this is also where our students get first hands-on, basically. We do not rely that heavy on dev kits. We think maybe it's a good idea to give them custom-built hardware, of course, with the necessary device trees, which is in that case maybe not that important in this point of time, but to give them custom hardware where they can basically tinker around a little bit and get a real-world application. Basically, the idea is always to use an asset tracker. The best, or maybe the best product to see a fast result, but this is basically also this kind of project we are dealing with from the 5th to the 7th, maybe up to the 8th semester, depends a little bit on the students. And to use this as an example that this as an example where we can basically teach exactly those skills. Yes, and we also give them the capability that they can keep this hardware if they would like that, because we think it is very important to encourage the students to work on their own sometimes. Mm-hmm. You cannot tell a person to be creative, finding a good algorithm from, 2 p.m. to 3 p.m. That does not work. You need to kind of encourage those people that they see, okay, this is a cool system, this is a cool project. I try to create something on my own. So basically, give them the chance to be creative and to be flexible, maybe.
Yeah, to be flexible, but also to enable their engineering spirit. Because we give them the building blocks with the Zephyr hardware, the software stack, for instance, so they can select what they need. Yep. And also to showcase Sven's background is another background as most of our students have. But to showcase them, we have a problem. We need a solution.
Exactly.
So the path between the problem and the solution in the engineering world is to come up with a solution. So this is what the students should learn. So they should see it's possible. I can do this also, and we lend them a guiding hand, so to speak.
And you see, it's kind of complex topics we would like to cover in there, of course, with a certain amount of time. But exactly as Kevin said, we are kind of educating the engineers for tomorrow. The thing is, what we experienced over the last years, this is a little bit of a downgrading process because I cannot tell you why this is.
And Tobias has to correct things.
It is like we cannot find a solution, not manageable. You cannot buy it, not doable. You cannot download this library, the problem is unsolvable. And this is something we would like to tackle exactly with this. We see this also in our circle where we basically work and live, heavily relied on downloading stuff, using board stuff. And this was always the case where we said, no, there must be a different way. And basically this is where we would try to use, basically our custom designs or what we think could be a good teaching.
And to always integrate the newest MCUs, used chipsets and stuff like that. It's a little bit a playful approach, or when we go to a embedded world, we see new products, we get samples, we want to use them.
Exactly. So basically this is something we have done in a lecture over, I think, 2.5 semesters, where students actually were able to track a track, send this data away. I mean, this is very complex stuff, to be honest. You have to collect the data, you need threads, you need synchronizing, you need a timestamp from somewhere. You need to kind of labeling the data, you need to send it away, and you need a backend. Of course, this was your part. But basically, to tell somebody that they can do this brings us a lot of students also and brings us a good feedback that it's really hands-on and kind of state-of-the-art technology regarding protocols and so on and so on. Okay, what else do we got here? This is not that important. Now it's a little bit time for critics. Like I said, or maybe not critics, but maybe to encourage you guys also, maybe we can find a solution there. We came from a world where, I mean, Kyle is obviously there shown. We come from this world where debugging was different than it is nowadays. And this is something where we are thinking that something has to get better or somehow optimized in a certain way, because when we started out programming embedded devices in the past, this kind of debug view was familiar. As I said, students coming in the 5th to 6th semester to us, they already have the basic lectures, still taught in this kind of manner. This is not that old. This is still taught in the year 2024 at TU Dresden at a different chair, of course. But this is still state of the art, and people are expecting this kind of view. They are expecting exactly this, an integrated IDE, which obviously costs a lot of money still today, and they are expecting a live view of variables. They are expecting just to press a button. They are expecting basically a program you start, and this is everything you do in there. It's very hard for us to tell people, okay, you can use an editor, whatever you like, maybe VS Code. You can use Notepad++, you can use whatever you like. Basically, it's just editing text files. But also in an IDE, we think there are some benefits. Maybe by just hitting the play button and to see this debug view is not a bad idea, maybe. Right now, we rely also heavily on Zephyr jailings and Zephyr tools running Ozone, which brings different problems, at least in our world. Flashing's not working, debug views not starting. Something like this, which is also hard for us to explain why this happens, because we cannot tell why this happens. I don't know. Sometimes it happens, sometimes it's not happening. And this is something where we think maybe in this ecosystem we could build something better together somehow. Just wishful thinking. But this is basically also the outcome from the student side there. They like the idea of having Zephyr and having basically a config-based system which they can tune for their needs. This is what we get played back, that this is a good thing. But the greatest problem also the students give us is the debugging experience, which is like they say, maybe something could be optimized. This is what is told to us. Okay, so basically just to conclude this, or basically to bring this to a summary, what we experienced over the last 5 years, that it is very well accepted, that this paradigm shift, which was introduced also in this morning, is very well accepted. People are they would like to deal with this, and they also see the need for this because systems are getting more complex. I mean, if you look 20 years ago, a microcontroller in a washing machine had just one task. Now it's sending data away, it's collecting stuff, it needs to be real-time constraints and whatnot. And this is very well accepted, at least what we see right now. Also, we think when dealing with Zephyr and when promoting Zephyr, also in the classroom, we are also doing this by mentioning company names. Meaning that we have also in the last years a lot of guest lectures from the company Nordic Semiconductors, from ST Microelectronics, from the sensor device. What is this? From the sensor devices. I think they're even sitting in Prague. Or near Prague, I think so. Also this company Memford, dealing a lot with metrics and diagnostics, sending diagnostics away over the air, which is a great way to kind of monitor your device on the fly. And we would bring those worlds together, meaning that our students get as early as possible in touch with people dealing with this kind of stuff, dealing with real-world problems, connected devices, and they know kind of the faces, the names, to get in touch, also to get some insights. And we had a really great conversation with the guys from Memford, with Noah, which did a live lecture with our students, that we did a live debugging and set it up, the whole Zephyr project to enable Memford. They did, of course, a little bit of marketing here and there. I think it's a must somehow, because it's a company, they need to earn some money. But they kind of pointed out the benefits from their system. I think they're also acquired by Nordic right now. And they brought in a very graphical way the benefits there, which we liked. Students said, this is a good idea. You see live data, you see diagnostics, you see why the system crashes, you see the reasons, you get the core dump, you get, even if you upload the symbol file, you get where it crashed. They all understood this, and we tested this live by just enabling this config underscore Memford equals Y, build, flash, voila, it worked, and everybody was, oh great. Interesting. I did not even know they work in Berlin. So also we see ourselves there to maybe open up some doors for future careers. If you have students which are very or highly enthusiastic in this kind of stuff, that you see there are companies here. They are in Germany. They may be in Saxony, Thüringen, wherever. You find them, but you need to know them. And this is where we also see our role there in the university context. Not just to tell them something and end there, to also tell them the whole story, that, like you said, you need the engineers for tomorrow. You need experienced Zephyr engineers or programmers or people understanding this kind of ecosystem. And we think there are a lot of great platforms available. For example, Thingy91, great platform. ThingyX, exactly. And basically this is where we also would try to get better, of course. This is where we also try to find more, how to say this, how to find a collaboration there somehow, that we maybe can find you guys as a guest lecturer in some talks there, maybe give some insights, maybe whatever. But that we get a broader community there, because right now in Dresden we feel very alone, to be honest, in the Zephyr world. Nobody wants to talk to us about Zephyr. And this is, I mean,
if there would be any meetings.
Maybe we can host something like this in Dresden also. You are very, very welcome there. And this is something which is important for us because we see the future there, to be honest. And this would be really, really great. And now is the time to talk to you about something else. Maybe, no, not this slide. I would like to give this slide. Because we also talked a little bit about using it in the... Do we have a little bit more time? We have, of course. We not always use it we not only use it in the classroom, we also use it in projects, to be honest. And this is our yeah, our software framework we decided for. And Kevin, maybe you can tell us a little bit about a project where we would like to incorporate Zephyr with some features.
I will very much. Okay, so can you go back this?
I go back.
Yeah, genau. So trying to give you a little bit of project outlook we have, or we had, like here, a little bit. Okay. Hey. Okay. So we are located on the transportation faculty, and road safety is especially a big topic. Sven mentioned the FUFO. The FUFO is here. What is the FUFO? FUFO is Verkehrsunfallforschung an der TU Dresden, GmbH. So it's a company. It means Accident Research Unit. It's a private company, but it's under the umbrella of the TU Dresden AG. So it's more or less a spin-off. And the FUFO is alarmed when traffic accidents happen and people are harmed. So they have 3 cars, but they go out on alarm with 2 cars. One car is the physician's car, so there's medical personnel on board, and one car is the technician car. So with the technician car, they go to the accident and they measure all how it happened, because they use this data they acquire there to do modeling things and to do statistics, why it happened, what was the incident response, etc. And the medical car is treating the patient, also to the hospital, and is looking for the outcome. How well did the patient recover, etc. And they all collect this data in a big database. It's in the GIDAS database, German In-Depth Accident Study. And we have some data from the FUFO. So for instance, this was the motivation, by the way, it's a little bit of project outlook. This was a M-Fund project that we had in 2023. It was called V2X for All. I go into a little bit of detail. And we saw in this slide a big change happened in mobility. So more and more bicyclists are on the way, and more bicyclists are getting harmed. So this is a problem. And this is a big problem because the city we come from, Dresden, is #1 in accidents with bicyclists. #1 also with the most dead bicyclists. Resolving in accidents, this was in 2023, this was in 2024, and I think we are on the way to 2025 also. It's not looking good. And our idea was for this project, is there a possibility that we use vulnerable road users that are pedestrians, older people, children, bicyclists, and the public transport? Is it possible to integrate these participants into the big V2X ecosystem? V2X stands for vehicle to X, to infrastructure, to vehicle, to pedestrian, whatsoever. It's a standard for communication system in the traffic world. Jena has also V2X enabled roadside units. That means if you, I don't know where exactly in Jena. Somewhere. But if you have a look at the traffic lights and you see a gray or white box with antennas pointing up and down, this must be a roadside unit. And this roadside unit emits information wirelessly. And in this information there are messages. And these messages are standardized. And like the infrastructure distributes or broadcasts messages like, this is the geometry of the roads. 2 lanes forward, 1 lane left, for instance. And the other information is signaling information, like traffic lights going green, 5 seconds, going red in 2 seconds. Something like that. And there are also messages defined for vehicles, like cars transmit, cars that are enabled to transmit. These are all new VWs, starting from Golf Mark 8. All of the ID cars transmit V2X messages. So, can we benefit from it? We can. Can these participants benefit from it? Not yet. So this was the rationale behind the project, and we wanted to make them participate in the system. And we did it with this. You see the tram here? We equipped this tram with trackers and with a
Zephyr.
Zephyr, exactly. And we built in certain kind of translator that translates the V2X message into a message like, for instance, a bicyclist can understand. A bicyclist has not the dedicated hardware that you need for the V2X ecosystem. So we needed something everybody has with, and that is a smartphone. And what you see here, this is what the result looked like. You see in blue, the blue pin is the mobile anchor. This is the tram in our case. And in orange, you see the V2X messages that the tram sees from other participants that are in the road. And you see in green another participant that is using the app. And here you define a warning circle surrounding you. And if some object is within this warning circle, you get a warning message. So this was the basic idea. This was the prototype that we had. So you could basically see a car that was equipped with V2X technology, but it was a little bit away, around the corner. You couldn't see it line of sight, but you saw it non-line of sight. And this is the idea. And we want to enable this principle and reverse it, so that also the people in the car can see the pedestrian, for instance. And this is what we want to do with this project. That is starting this month. So it has started already. It's an EFRE project. And we want to raise also the VRR and public transport awareness. Why is it necessary? Because we see this in our city. You wouldn't believe how many accidents happen between bicyclists and trams. Way too much. And this is why we want to improve this aspect a little bit by using technologies that are already within the Zephyr stack.
Exactly. So basically one main technology we would like to use there is basically Bluetooth Low Energy, especially the Bluetooth Low Energy audio, the AuraCast, which we would like to kind of use for sending away or sending out messages to warn people, having AuraCast equipped devices, headphones, and maybe basically headphones. Because this is a picture we see a lot in the city of Dresden, that people are driving by bike with their headphones on. And this is really a nightmare. If you're in the car and you're behind them, you can do whatever you like. They are not driving away. And this is a problem. And this is where maybe Zephyr can help, because this technology is already in there. And you can basically use there. And this is something where we also have a lot of students which are we have a lot of bike enthusiastic students. They are basically not that, oh, maybe I can program something. This is, you catch them with this kind of topics. And this is where they say, okay, I like this idea, I like this approach. Okay, I have to learn Zephyr, no problem. Something like this. I mean, maybe it's not that easy, but you catch them with a special topic. And exactly this is where the engineering point of view comes into play. And this is where we think also the students could make a difference there, and maybe also this project makes a difference there. Another technology we would like to use, which is not natively direct in Zephyr right now, is the stacked new radio or the stacked NR Plus standard coming hopefully soon. And maybe the non-terrestrial communication, which is hopefully also coming soon. But basically, we rely on technology which is already built into the stack, or in this whole ecosystem, so to speak, to use it for cool applications that make maybe the world a little bit safer. This is our mission in the first place. Of course, we have some animations there. Okay, so thank you very much for your attention. Thank you very much for your time. And also,
you can find us here. Drop by.
Thank you very much for your talk, for your insights. how do you teach and how do you do research? Any questions about this project or about this teaching approaches?
So you raised that question about debugging in Zephyr. Just last week I installed on my Windows laptop Zephyr on the VSL2, and then I use CLion. And CLion and CLion has a feature that installs some kind of client into the VSL. And in the VSL, then I installed also, I used the STM microcontroller and I installed that STM32Cube command line interface. And then I just started my CLion on the Zephyr project and the Blinky sample, and I can just set a breakpoint and that works.
This is something we learned today, but one question also into your direction. Does it work with real-time tracing of variables? If you let the code
I don't know,
run,
I just run the Blinky example. So, yeah.
the RTT, but you have no variable. The RTT works, this is no problem, this works. Also the command line, this is not a big deal. But we would like to see a debug view where you can run your code and see a live update of the variables which you can choose independently of each other. Maybe in a 2, 3, 4 Hertz cycle. It's the IP of Sega.
Okay. So we have some open space tomorrow just to mention, so it would be great just to set it up here and do live demo and live hacking, try it, and you will find out.
Just a quick question, to a question that I should have asked to everybody using Zephyr in university courses. So about the evaluation, how do you evaluate students, and if any part of the evaluation involves practical work on Zephyr?
We kind of evaluated basically on how they liked it. So basically we asked them, did you get along? Where were the problems? Because our student numbers are not that great, to be honest. We have maybe 10 throughout the whole semesters, because we are, like we said, we are starting very late. People are orienting in different directions. So basically we get already the hard, or maybe the embedded enthusiasts already in this point of time. So basically we just asked them how they liked it, what they maybe what they did not like, and what can we make better. So basically we go into basically a discussion with them. This is our plan, at least for now.
Anything more? There.
Is your custom hardware, your PCB open? Yeah. Can you share the design, or is it public somewhere? And do you?
I can share it, no problem. It is not public yet, but we can make it public. We have a little collection with me, or we have a little collection here. Choose whatever you like.
And in your course, do you encourage students to look into the PCB and how the configuration is done, or is it more like a communication level?
Yes and no. This depends a little bit on the audience you have there. Sometimes you have audience which is really into hardware. They would really like to know, okay, which kind of sensor, which kind of GPIO is used there. But most of the time this is, you just hand it out as a dev kit. Basically it's like they use whatever you give to them. So we decided to give them custom hardware. You can also give them a dev kit from STM or something like that. Maybe, or sometimes they are not that much into the details, to be honest. More into function.
Any more questions here about this? Not the case. So thank you very much again.